Hello and welcome to Intro to Chem Lecture G, Dimensional Analysis. Dimensional analysis sounds kind of scary, but it's also called factor label. I prefer to use the factor label name for it because it's exactly what we're going to do mathematically. We're going to create conversion factors, and we're going to leave their labels on them. I know you don't usually like to write out the words. You like to write down as little of your math work as possible, but I'm going to ask you to leave the labels on because we're going to treat those words just like they're numbers. So let me show you what I mean. Some really hard algebra concepts we need to review first. So 1 divided by 1 is 1. 5 divided by 5 is 1. 623 divided by 623 is, yeah, you guessed it, 1. Okay, it also works for elephants. Elephant divided by elephant equals 1. They'll cancel. So think of this in terms of science. If I have liters and I divide that by liters, liters divided by liters will cancel, and that equals 1. Okay, so that's the first really hard algebra concept you need to remember from way back in the day. Okay, here's the next one. 1 times 1 equals 1. 5 times 1 equals 5. 623 times 1 equals 623. Elephants times 1 is going to equal, elephant. So the math concept here was anything times 1 is itself. This is what led us to algebra. That's why if we have 5x equals 10, we're allowed to divide both sides by 5, because 5 divided by 5 is 1, and we're multiplying the x by 1. As long as we do the same thing on this side, we're dividing both sides by the same thing, we're essentially just multiplying by 1 here. The 5's cancel, and then of course we have x equals 2. So we're going to use this same concept, and we're going to add some factors to it. So what I mean by conversion factors, I'm going to scroll this to the other side so I've got some work room over here. So we'll hide the elephants. Inches to centimeters. Here's our relationship. For every 1 inch, I need 2.54 centimeters. Every 1 inch equals 2.54 centimeters. These are essentially the exact same measurement. So if 1 inch equals 2.54 centimeters, they mean the same length. So if they're the same thing, just different names, 1 inch divided by 2.54 centimeters, I'm taking a distance and dividing it by itself, that's going to equal 1. 2.54 centimeters then divided by 1 inch, again I'm taking a distance and dividing it by itself, that's also going to equal 1. So since anything divided by itself equals 1, we have two different conversion factors. So if I have an object and it's 4 inches long, and I want to know how many centimeters that is, I start with my 4 inches. I'm going to multiply. We're not doing proportions. We're going to be multiplying in the factor label method. And I look at my relationship and I say, well, I want the inches to cancel. So whatever I'm trying to cancel goes on the bottom. My relationship says 1 inch. I put the 1 inch on the bottom. It says that's equal to 2.54 centimeters. I put my 2.54 centimeters at the top. Inches are going to cancel. And now I just have to do the math. So I'm going to pull up my calculator. 4 times 2.54 equals 10.16. So 10.16, and the units I have left are centimeters. One of the mistakes I see students make, you're doing so many proportions right now in your math, you automatically want to make this a proportion. You want to put a line here and put a 1, and then you end up cross multiplying. That's not a proportion. It's not an equal sign. You're just multiplying. You're multiplying fractions. You multiply straight across the top. So you have 4, the inch canceled, so it's gone, times 2.54 times centimeters. When you look at the bottom, 1 is all that's left at the bottom. That's where we get our 10.16 centimeters. All right, we can do other conversions. So let's scroll down here and look at the English measuring system. We have some really interesting ones here. So inches to hands, feet to yards, you know, yards to rods, poles to furlongs, furlongs to miles, miles to chains. We have some, apparently, a pole is not always a pole. There's a woodland pole, there's a plantation pole, and there's a Cheshire pole, which are all different lengths. Poles into feet or feet into chains. So we have lots of different inches into links. So we have lots of different conversion factors that we can find here. So let's stick to something a little simpler. Let's look at inches to hands. So if any of you like horses, we measure horses in hands. So if they say a horse stands 12 hands high, and they're measuring at his shoulder, how many inches is it from the ground up to that shoulder, the back of the horse? So we have hands and we have this factor. So we know that there's 4 inches in every one hand. So our starting point is the 12 hands. We're going to make a conversion factor. We want the hands to cancel. So when we make our factor, we have 2 choices. We can put the 1 hand on the top per every 4 inches, or we can say there are 4 inches per every 1 hand. And I need to know which one to pick because both of these equals 1, right? That's the same thing, so that's 1 and that's 1. So the one that I want to pick is the one where hands are on the bottom. If I put the 1 hand on the bottom and the 4 inches at the top, then the hands are going to cancel. Hands divided by hands cancel. Because remember, we're multiplying here. Pretend this line goes all the way across the whole thing. So you just have 12 hands times 4 inches over 1 hand. The hands cancel. I have 12 times 4. That's 48 inches. How many feet is that? Well, you already know this one in your head, and you already know that in order to turn inches into feet, you're going to divide by 12. The reason that works is because every 1 foot equals 12 inches, and then our inches cancel, and what you end up with is 48 times 1 foot over 12, because notice the inches canceled. So 48 divided by 12 gives me 4 feet. So the back of that horse is 4 feet tall. Okay, that's the way dimensional analysis works. Now, if you want more help with dimensional analysis, how that works, if my explanation didn't work really great, try Khan Academy. It's going to be in the math section. If you just search dimensional analysis or unit conversions, you're going to find some videos from Sal Khan on how to do that. And I don't want to play a bunch of his videos. I want you to learn to go to his website and look for help with your math or with your chemistry. But this dimensional analysis, this how do we convert units, is going to be in his arithmetic pre-algebra section here. Okay? You can also search YouTube itself. Search dimensional analysis, and you're going to get a lot of different teachers showing the same work. Dimensional analysis is one of the methods, one of the techniques that the state puts into our core document that says, I am supposed to teach you during chemistry. Learn how to do it. It'll make the math easier. It'll turn physics, when you take it next year, into nothing but conversions. Okay, I want to take just one last minute here and show you how this applies to chemistry. So if you look at reference table S again, there are going to be a number of pieces of information in chemistry. When we look at them, they're already factors. They're already conversion factors. So if we just look at an example, and I'm just going to take lithium here towards the top of the chart, and we highlight lithium's data. When you look at the units up at the top, ionization energy and density are already conversion factors. Do you see that backslash? Backslash means per. So if I look at lithium's information for first ionization energy, when I read this, it says 520 kilojoules per mole of lithium. It's already a conversion factor. Okay? So if I want to know, if I say it took 1,500 kilojoules of energy to remove electrons using the first ionization energy, how many moles of lithium were there? We just do factor labels. So we start with our 1,500 kilojoules. We look at this factor up here and say, oh, I want kilojoules to cancel. So when I set up my factor, I'm going to put my 520 kilojoules on the bottom and my 1 mole at the top. So this way, the kilojoules cancel. Now I'm going to show you the math. You don't have to always do this, but if I simplify this, I have 1,500 left. The kilojoules cancel. I'm multiplying that by moles. Across the bottom, 1 times 520 is 520. And the kilojoules canceled, so that's gone. All I have are moles left. Moles are what I wanted, so now I just have to do the math. So I get my calculator out, and I do 1,500 divided by 520, and I say, oh, there was approximately 2.8, correct number of sig figs, 2.8 moles. Okay? Density works the same way. So if we look at the density for lithium, we can, of course, use our density equation always, right? Density is mass over volume. But if I have a problem that says I have 50 cubic centimeters of lithium, what would its mass be? I can plug the numbers into my density equation. That's not a problem. I can put the density in here. I can leave the mass blank. I can put the 50 at the bottom and just solve. I can also do this with the factor label method. So 50 cubic centimeters. My factor for density over here says that there are 0.534 grams per cubic centimeter, right? Grams per cubic centimeter. So the cubic centimeters are already at the bottom, so that's where I want them. So I'm going to put my 534 grams on the top and my cubic centimeter at the bottom. The cubic centimeters cancel. I have 50 times 0.534 grams, and I have 26.7 grams. correct sig figs. There's no decimal point here. We'd have to round that to like 30, but unless they ask for sig figs, don't panic over it. So 26.7 grams. Okay, there's going to be many things that we run into in chemistry that do have this relationship kind of thing that we can set up factors for, and it will make your life easy. Obviously, anything that's on table T, feel free to use the equations. If you had 0.534 equals x over 50, you're still going to do 50 times 0.534 to solve for that, and you're still going to get 26.7. So don't feel bad if you prefer using the equations for some of the math. But there will be some math later that we don't have an equation for. And if you take the time to learn this dimensional analysis, it'll make that math much easier when we get to it. Okay, again, remember, if you need extra help, come see me after school or check out other resources, remembering there's always Khan Academy and other educational videos on YouTube. That's it for Intro to Chem. On to Unit 1.